I'm Anil Kumar, and in this video we will understand how to sketch graph of reciprocal trigonometric function, and this time we are taking y equals to cot x, cotangent x. As you know, y equals to cotangent x, it is reciprocal of tan x, right? So 1 over tan x. Now just a quick reminder, tan x, as you know, is ratio of sin x over cos x. So sin x over cos x. So first we will sketch the function y equals to tan x, and then we will sketch reciprocal of tan x to get cot x, right? So this is how we do it. So this is the coordinate plane. Let us say the intervals are pi by 2. So we'll just draw vertical asymptotes at pi by 2 for the time being. These vertical asymptotes are for tan x. Tan x is sine over cos x, and as you know, cos x is 0 for pi by 2. So when you divide by 0, you get undefined number, which is represented by the vertical asymptote, right? So these vertical asymptotes are for zeros of cos x. So these are zeros of cos x. As you know, the zeros of sin x are at 0, pi, right? So they are at intervals of 0, pi and 2 pi, correct? So at 0, pi and 2 pi, we will have zeros of the tan x. So when you sketch the function tan x, it will look like this. So let me just sketch it here for you. We are not getting into details of sketching tan x. In this exercise, we are going to discuss how cotangent x will be drawn, right? So we are assuming that you know how to do tan x, right? So kind of like this. Okay, so what we have here, this is 0, this is pi by 2. Oops, this is wrong for us. Okay, so that is pi. Okay, it's not so wrong. Anyway, so what we will do is we will draw vertical asymptote here. Okay, not bad. It will help us later. You'll see how. That is minus pi by 2. This is minus pi for us. Okay. Okay. So let us say that we have drawn the tan function from minus pi to plus pi, right? So that is the interval during which we are doing it. So from minus pi to plus pi. Correct? So these zeros are zeros of sine, and the vertical asymptotes are zeros of cosine for the given function, which we have done as, I should write now sin x first. Sin x over cos x, which is tan x. So that's the graph for tan x. Now from tan x, we are going to sketch cotangent x, correct? So let us do it in the shades of blue, or rather blue and green. Okay, now for cotangent x, it is reciprocal of tan, right? So that's the graph of tan. So at the zeros of tan, we will have vertical asymptotes for cotangent, right? So we'll have these parts as a vertical asymptotes for the tan function, right? So these zeros will get translated to vertical asymptotes for the tan x. Okay, so these are the vertical asymptotes for tan x. 1 over 0 is undefined. And whenever the function is positive, the reciprocal is going to be positive, that is clear. The other thing is, if it is approaching infinity, then the reciprocal will approach 0. Do you get the point, right? So basically for cotangent x, and when it is approaching 0, it will be infinity. The graph will be kind of like this. you see that? It will be like this. So this 0 will get translated to plus infinity when you are approaching from the positive side. And this 0 will be translated to negative infinity when you are approaching from the negative side. Do you understand? And here you'll have a 0 for cotangent x, right? So it's kind of like this. Do you see that? So that is how it is going to be for cotangent. Correct? So it is kind of crossing it like this. So that is the graph for cotangent. You can also think cotangent as equal to cos x over sine x, right? That will help you to understand the concept that when cos x is 0, we have zeros for cotangent x. Do you see that? These zeros are zeros of cos. And when sine x has zeros, that is 0, pi and 2 pi, we'll have vertical asymptotes for cotangent x. So that's another way of looking into it, right? So for cotangent x, sine x is not equal to 0, right? That is a restriction. Perfect. So sine x is 0 at n pi, right? 0, pi and 2 pi. So for cotangent x, we can write the domain as x belongs to real numbers, where x is not equal to n pi, where n belongs to integers. Do you see that? So that is how we can write domain. And the range for this function is y belongs to real numbers. There's no restriction. It goes from minus infinity to plus infinity. Correct? So that is how we can sketch the graph of cotangent x. And the time period for this is pi, just as the time period of tan x. So the time period for cotangent x is pi. I hope with this graph things are very clear that cotangent x should be treated as cos x over sine x. Now sine x equals to 0 gives you all the vertical asymptotes for cotangent x, which are at n pi, right? So that's how you should do it. I hope that they make things clear. Thank you and all the best.